All right, so what we're going to be learning about today, or at least introducing ourselves to, is functions. And when I think about pre-calculus, this is really the basis of pre-calculus. Pre-calculus is the study of different types of functions and their properties. Of course, pre-calculus is a class that's meant to get you prepared for calculus, but really at the core, we're learning about these things called functions. So why do we care? First of all, functions help us model and understand the real world. As mathematicians, one of our goals is to take something in real life and give it some kind of function structure. And usually that helps us either predict things or understand it a little bit better. So they're really, really important in real life applications. Functions are also everywhere. No matter what class you take, you're going to be seeing functions in some capacity, especially in the sciences. And then at the very least, you need to understand functions for calculus. Calculus is all about understanding the change of functions. So in this class, we're going to be talking about a lot of functions and a lot of properties. So what is a function? A function is a rule that assigns every element of a domain. So here, I'm going to go ahead and highlight some stuff. A function is a rule that assigns every element of a domain to exactly one, and this is key here, exactly one element of a codomain. Now, if you're reading along in the book, which you should be doing, this is a little bit more pinkies up than what the book says. Okay? And we'll kind of go through this a little bit more, but this is the precise definition of a function. So again, a function is just a rule that assigns every element of a domain to exactly one element of a codomain. Okay? Now, you might not have heard these things before, so let's kind of talk about them a little bit. So domain, you can think about these as just your inputs. Okay. And we're going to have a video later on that actually goes into domain a little bit more carefully than what we're going to do here today. Codomain is the possible outputs. Okay. And then the range, which hopefully you've heard about, this is the set of outputs. So these are the things that actually come out of your function. Now notice that codomain and range, they look very, very similar. Codomain is the possible outputs and range is the actual outputs that you get. So let's look at some examples. Okay. So here's our first example, and this is a pictorial representation of a function. So notice here on the left, we have our domain, which in this case is just the numbers 1, 2, and 3. And what is this function doing? It's sending 1 to -1. It's sending 2 to -1 as well. And it's sending 3 to 10. Okay, so our domain in this case would be, and I'm going to use set brackets here, the numbers 1, 2, and 3. Again, domain is just our inputs. What are we inputting to the function? Our codomain, okay, it's the set of all possible outputs. So what are the possible outputs that we have on the right here? And again, I'm going to use set brackets, -1, 5, and 10. Okay, but what's our range? What are the outputs we actually get? We get -1 and 10. Okay. So this is the difference between codomain and range, though. Codomain is the set of possible outputs, and range are the actual outputs themselves. And notice the range is included, or is a, pinkies up everyone, subset of the codomain. Another example is f of x equals 2x squared plus 1. Now, this is normally how we're going to be using functions. This is what we call function notation. When you see this f of x here, this means f is a function of x. Okay? X here is the what we call the indeterminate or the independent variable. That's what we're going to be plugging values into. And then f is going to record what the outputs are. Okay? Another way we might phrase this too, it's often seen as y equals. Okay, so instead of f of x, we might replace that with y. So this could be phrased as y equals 2x squared plus 1. Okay. Now the domain of this function is -infinity to infinity, and we'll talk about that in a later video. How do you actually find that? And its range, if we were to graph this function, the graph looks like, and we're going to learn how to do this as well, the graph looks like this. where this is the number 1 here. So all of our outputs are 1 all the way up to infinity. Now, if you're not comfortable with what I've written here on the right, this is what we call interval notation. Okay, so the domain here, this is the interval from negative infinity to infinity, and the range here is the interval from 1 to infinity, where we have a closed bracket here on the number 1. So to give you guys a visualization, negative infinity to infinity just represents the whole real line. Okay. Now 1 to infinity, this represents all the numbers that are bigger than 1. So let's say 1's right there. And it also includes 1 as well. Okay. So hard bracket means include the number. And what we call a soft bracket or an open bracket means you don't include. Okay. And as we go along through the semester, you're going to see we're going to use interval notation pretty much consistently. Now, functions don't always have to be in terms of just numbers and things like that. Again, remember, functions help us model real life. So here's an example of a function that's sending an NFL team to the number of wins they got during a season. Now, if you guys are up on your NFL things, this is actually the 2019 season. So in this case, we have the Packers are being sent to the number 13 because the Packers won 13 games last semester. The 49ers are going to 13. Patriots only won 12 games. And then poor Raiders here only won 7 games. Okay. So here's another example of a function here. This is, again, a real life example. We're not just dealing with numbers here. We're dealing with NFL teams and number of wins here, which are numbers, but nice to have a little bit of variety. Now, what's our domain in this case? Our domain, and again, I'm going to use set brackets, Packers, 49ers, Patriots, and Raiders. Okay, what's our range? So again, remember, range is our output. What are we actually getting? In this case, we have 7, 12, and 13. Let's look at some non-examples. Okay, things that are not functions. So again, with a pictorial representation here, here's something that's not a function. Okay, and I'll let you guys look at this for a second. Now, why is this not a function? Okay, now you might be tempted to say, well, 2 and 3 are both being sent to 8. Okay, however, that's okay for a function. Functions can send 2 inputs to the same place. That's okay. The problem with this thing, I can't call it a function, but this picture here is really the 1. Okay, what's happening to 1? This thing is sending 1 to 6 and 7, and that's breaking the rule of functions. Remember, functions can only send an input to exactly 1 output. Okay, so this is where this thing is going horribly, horribly wrong. Okay, so this would not be a function. 2, now what if we let our input be the number of losses in the 2019 season? So this is the number of losses in the 2019 season, and our outputs are the teams themselves. Okay, this would not be a function. Again, why is this not a function? Notice that 3, Packers lost 3 times last season. 3 would be sent to both the Packers and the 49ers. And as we all know, the Packers and 49ers are not the same team, not at all. So this would not be a function in this case. Again, because 3 would be sent to both the Packers and the 49ers. Again, breaking that one rule of functions that you can only send 1 input to exactly 1 output. Now, how can you tell if something is a function? What we've been doing is we've been analyzing inputs and outputs. So if you're given functions with tables or pictures, this is a really, really good way of doing this. If you're given a graph or a curve, then we have something called the vertical line test. And this is another way you can use, or another method you can use to determine if something's a function or not. So the vertical line test says the following. If a vertical line test passes through a curve more than once, Okay, so again, keywords here. If a vertical line passes through a curve more than once, the curve does not represent a function. Okay, so again, if we have a curve and we draw a vertical line and it passes our curve more than once, that is not a function. Otherwise, I use a different color here. Otherwise, the curve represents a function. So here's two examples. I'm going to switch colors for a second. So here on the left here, we have what we'll know as a cubic function later on, but this is a function. Notice if I draw any vertical line, it's only going to pass through the graph once. Okay, so this would be a function. Now on the right here, though, notice that if I draw this vertical line, it passes through the graph 1, 2, 3, 4 times. So this would not be a function. Let's use proper English here. Not a function. Okay. So this is what we call the vertical line test. Again, if one single vertical line passes our graph at more than one place, it's not a function. Otherwise, like we have on the right here, if any vertical line only passes our graph at most once, it is a function. And lastly, and we'll conclude with this, ways to represent a function. We've seen a lot of these today, but there are 4 main ways to represent a function. Verbally, so communication. So again, let me go back up to our NFL example here. This function, as I described, was taking an NFL team to the number of wins they got in the 2019 season. Okay, so that would be a verbal representation of a function. Numerically, we've seen this before as well. Think about these as tables. So we can represent functions in tables. Graphically, this is, well, the graphs. And algebraically, this is more of our function notation. So your f of x is equal to, I'll just put blah, something. Okay. Now in our activity today, you guys should be looking at different ways of representing a function and sort of getting some practice with that.